This is a corroded FunHouse MPU board, and I've already removed C31 and J210, and you can see I've removed all of the corrosion impacted components and the headers here, just to make sure there's no corrosion hiding under these headers, the same as it was hiding under these headers. So the next step is to suck all these through holes dry with my Hako, and then sand down and see what kind of trace repairs are required. So I have all the through holes cleaned out, or mostly cleaned out. Some of these I'll need to clean out after I sand the traces down. I've got to get rid of all this corrosion on here, otherwise it'll just continue to creep. And the way that I do that is I have this 12-pin .093 Molex connector that's left over from something, and I just use it as a sanding block with some decent modern sandpaper, and it comes off pretty good. So let's see how it does. Sanded down pretty good. I may have to clean up a few areas, and I've been able to identify at least one trace that needs to be rebuilt. It's this tiny trace that goes from this pin down to the lower right pin for the ULN 2803. So you can see that fracture right there. No big deal. I'll probably run a jumper from here to there for this one. I don't like trying to tack solder in such confined spaces. In fact, I don't like tack soldering at all, because it's just not a good solid mechanical joint. So I'm going to take this outside and wash it down, let it dry in the sun, get rid of all the, I guess, sanding residue that's stuck in these through holes, because if you don't get rid of that before it dries out, it turns to like concrete in there. I've put a nice layer of conformal coating on here after sanding down to mostly bare traces, or at least until I was positive that all of the corrosion had been abated. So this is the conformal coat that I use. It's a silicone conformal coating from MG Chemicals. This stuff's pretty pricey. It's like 17 bucks a can, but it sure beats spending time tinning traces like I used to do when I first started out. This is something that I do for every power driver board that comes through the shop. I'll replace C2, and you can see here, I know you're at a high altitude, but I have scratched up these traces to make sure that there's no corrosion here. This cap often leaks and corrodes these traces and severs the 12-volt regulated power. Replace C4, and I'm going to replace C5 and C11 here. C11 was bulged a little bit, so we need to get that out of there and replace that also. The rest of these caps are just fine. There is no reason to ever change these caps unless you absolutely know that they've failed. These two caps replace the giant capacitor that used to be in the back of Williams 3 through 11 games, I believe, the 30,000 microfarad cap, and nobody ever replaces it, or nobody should. So never replace these. I've taken off all the headers, and I've inserted a blocking diode here on the end of this big sand resistor, and the reason I do that is it is possible to connect one of the voltage connections here, voltage output connectors, to some of these connectors down here, which cross connects the 70-volt coil power with the 20-volt flash lamp power, and ends up blowing up C11. So this blocking diode will prevent that from ever happening. But this is a good thing to do, is just take your meter, set it to continuity, and then it takes just, well, time me, not too long to get through testing all these fuses. So we're going to test all those before we get it back in the back box, and they're all good. And then the next thing to do is put your black lead on ground doesn't really matter. We're checking for continuity. And we want to do a quick check on the tip 102 transistors. So just run right through and touch the tab of each tip 102. If you get continuity, you'll know that that transistor is shorted. Now this test doesn't work with the tip 36s. All of those are going to show continuity. Now you can check the pre-drive tip 102s if you'd like to. And you can also check the tip 102s in the lamp matrix section over here too. Now to check the tip 107s in the lamp matrix, you have to connect to the 18-volt power source, because those are these transistors are the gatekeepers for the 18-volt power source. And we'll just do the same thing. Run through. Whoops. I've got continuity there. So this transistor is probably failed. So I'll switch my meter over to diode check. Red in the center, black on the flanking side. It's good on one side, shorted on the other. So that transistor needs to come out. And so I'll replace that and put all these headers back in that I've taken out. These are the GI headers, these three: power output header, power input headers, ground header. These two headers, these are for flash lamps. These were really tarnished, so I don't usually replace those, but this time I'm going to. And also the 12-volt input power there. So moving on. We have a new tip 107 installed, and I typically mark the top of them with a gold stripe with a Sharpie. I've got headers installed all the way around. I use this when I have to split a header to make up these 12 pins here. I use 6 and 6, so I just use an old female connector to make sure that they line up. I have replaced the trace that blew up right here. It goes down to right here with a jumper on the back. I used a pretty good gauge jumper to replace the trace. The rule of thumb is use a jumper that's going to at least carry the same current as the trace was carrying. I always remove the solder from the LM323K connection and then reflow new solder in. I don't typically note that when I do these repairs, but I always do it anyway. There's some residue here from a prior repair, not mine, somebody else's. That'll come off when I clean up this board with some Castrol Super Clean. And I think that's about it. Next step is to, well, I'm going to wash it down first, and then we'll put it into my white water and see how it does.
Way to go!
So here we have a WPC power driver board and a WPC MPU board. I don't know what game they're from. It did not come with ROMs. And I have finally gotten to the bottom of everything on these games. The last remaining problems were induced by the prior repairman, who fractured some traces right at the through holes for some of the components they were replacing at the Q54 and Q56 areas. So we've got this thing all working now, and it took quite a bit. In and out of my white water about 4 times with this thing. I hate that. C5, C11 replaced. C11 was domed. C2, C4, headers all the way around. Standard fare. Nothing really unusual except the prior rework, which is always suspect. MPU board, input filter cap, J210, and this is the one that was corroded severely. So I have taken care of that, and you saw that I rolled in some of the pictures during the process. So let's put it into test. I've just gotten through playing some whitewater. So let's go through solenoid test. And it was the slingshots that were impacted by that problem. And the back box GI. Oh, which I don't have plugged in. Let me plug in my GI tester. Where is my GI tester? There it is. Go. Let me go through all of them one more time. The GI is working. We'll do lamp and flashers at the same time. See, all lamps are working. The flashers are cycling on the back box. And that is it for the driver board test. Oops, sorry. So let's go through. I don't know why that's making, or it's making a call to the soundboard periodically. That's a very strange thing. Let's put it in switch test and connect my switch tester. And here we are with the switch matrix test. All of column 1 and all of row 1. So all that repair work that I did in the switch matrix section looks like it worked out perfectly. So that is it. I'm going to make sure I've got these cables, these ribbons connected properly to the soundboard. Other than that, I think these boards are good to go. Thanks again for sending them, and thanks again for your patience.